Hello everyone, hope you guys are having a wonderful holiday. On this video, I'm gonna get started with the solution for our test on a video. So in the first question, it is asking which number represents Avogadro's number. And as you know, this is a super easy question. Most of you got it right. This is 6.022 times 10 to the power of 23. On the second question, it's asking to determine the molar ratio of sodium carbonate to water in hydrated sodium carbonate. So I wanted to tell you about this before we go ahead. In my worksheet, you have seen in the solution that I have sometimes compounds written like this, multiply by H2O, and they would have, like, let's say 7 of them. This is another example. So this sodium carbonate, when it is making a combination with the 7 moles of water, it makes compounds called hydrates. Hydrates are coming from the word hydro, meaning water. Hydro means water. Okay, so when you have crystals like this, they are actually in a crystal shape. The water molecules, they are inside those crystals, and they can come in this kind of ratio, like 1:7 ratio, and sometimes they come in this way, where they have 1 mole of sodium carbonate for 10 mole of water. So when you even do the molar mass of this mixture, you need to, it's not a mixture, it's like a combo. So when you have a molar ratio of this, molar mass, So when you're looking for the molar mass, it's written as MM. So molar mass. We have covered this many times. So you need to take into account for example, if you look up the sodium atomic mass, it's 23 multiplied by 2 plus 12 of the carbon, and then 3 times oxygen, 3 times oxygen is 16, and then plus you got 10 hydrogens, 10 times 2 hydrogens plus 1 mole of oxygen, like this. You need to add them up, okay? You need to add it up as it's shown in here. So in this question, it is asking the molar ratio of sodium carbonate to water. And as you see in this mixture, we have 1:10 ratio in this combination. This is the crystal hydrate. Okay, and then I'm gonna move on to the next question. Indicate the statement below as true or false. No partial point will be given if you don't get both of them right. So it says mass of 1 mole of substance is a molar mass. It is true. We know that the molar mass unit is grams per mole, meaning x grams per 1 mole. For example, if you have oxygen molecule, it will have 16 times 2, which is 32 gram per mole, meaning for 1 mole of this, for 1 mole of O2, you have 32 grams, and that's why this is true. Volume of any gas at room temperature is 22.4 liters. It is not correct. It is not at room temperature. It is actually at standard temperature and pressure, STP, and this temperature over here is 0 degrees Celsius. But we covered in our lab for stoichiometry that at room temperature it is 24 liters. Also in this statement, it says volume of any gas. It's not volume of any gas. It is 1 mole. The volume of 1 mole of any gas at STP is 22.4. The volume of 1 mole 1 mole of any gas. So it doesn't tell us how many moles in here. It could be 2 moles, 3 moles, we don't know. So it's not giving us the value. So the correct statement is saying if you have, I'm just going to clear this out. So correct statement is volume of 1 mole of any gas at STP, this is not room temperature, is 22.4 liters. That's why this is wrong. Question 4, it is asking us to choose the mass of oxygen atoms in 3 moles of NO2. So in 1 mole of NO2, we got 1 mole of nitrogen and 2 moles of oxygen, right? But in 3 mole, automatically you have, for NO2, you got 3 moles of nitrogen and 6 mole of oxygen. And the only thing you need to do is to find the mass of it. So we have the formula N equals to mole equals to mass divided by molar mass, the unit of this guy. So this is mass and this is molar mass. So right now you've got with you 6 moles of oxygen is given to you, and you have the molar mass of oxygen, which is 16. You need to find the mass, and from here you know that M equals to N multiplied by mm, and this would be 6 times 16, which would be 96 grams. Okay, because if you write it down in units, it would be 6 mole multiplied by 16 gram per mole, and then mole and mole cancels out. You got 96 grams, and that makes the answer D. So now for question 5, what is the mole ratio of reactants correspondingly when the following reaction balanced correctly? So for balancing, we're gonna start with checking out each element. So let's check out the nitrogen. You have 1 nitrogen here, 1 nitrogen here, so you're okay with nitrogen right now. And then let's check out hydrogens. You have 3, you have 2 in here, and then oxygen you got 2 and then 1 in here. So the easiest would be, let's start, and then you have also oxygen in here. So oxygens are okay, but your hydrogens are a problem. So what we can do here, we can try to make hydrogens equal to each other by multiplying this hydrogen by 2 and then multiplying the other hydrogen, the water, by 3. So now this makes 6 hydrogen here, and then you got 6 hydrogens here. And then let's check out our nitrogens right now. You got 2 nitrogens here, and then you got 1 nitrogen here. So what we need to do, we multiply this by 2. So now you have nitrogens are okay, your hydrogens are okay, but your oxygen is off because you have here 2 oxygen from here, 3 oxygen from here. So altogether makes it 5 oxygens, and then you have only 2 oxygen in here. And in order to make this one equal, we're gonna do 5 over 2 for this oxygen. But we know that we can't write the fraction, so we're gonna multiply everything by 2, which will give us 4 NH3, 5 O2, and then 4 NO, and then 6 H2O. And that's why our ratio, mole ratio for reactants, we know that in the chemical equation, these coefficients are showing us the mole ratio. That means 4 mole of NH3 goes with 5 mole of oxygen, gives out 4 mole of NO, and then 6 mole of water. So you need to know that the coefficients are giving you the molar ratios. And now it's asking us the molar ratio of reactants, which is 4/5, and that's why the answer is this. Okay, correspond the following. So mole ratio of reactants. It's not 5/4, but following because we're following this order, the first thing comes is NH3, so 4NH3, and then 5O2. This is the ratio that you have. Okay, so now we're moving on to the question 6. It is telling us what is the molar mass in gram per mole of a substance if 0.5 mole of the substance has 20 grams. So we know that the formula N equals to M over mm, where m is the mass, mm is the molar mass, and this is number of moles. Now it's asking us the molar mass, so this would be mm equals to m over n, and you're given that the mass is 20 grams, so you write here 20 gram divided by 0.5 mole, and this is gonna be 40 gram per mole. This is your answer, and that's why it is C. So, for question 7, what is the total number of nitrogen atoms in 2 mole of ammonium nitrate, NH4NO3? You need to know that from the first semester we had to memorize them. This is ammonium ion, NH4. And then this is nitrate, which is NO3 negative, nitrate. Okay, so what is the total number of nitrogen atoms? It's not telling us the number of moles. It is asking us, exact number of atoms. So if you have 2 mole of this, so if you check out for 1 mole of ammonium nitrate, as you see, you have 2 mole of nitrogen, right? 2 mole of nitrogen. Let's do hydrogen. You got 4 mole of hydrogen and then 3 mole of oxygen. But we don't care about them, because it's not asking us that, it's asking for nitrogens. So for 1 mole you have 2 mole of nitrogen, and for 2 mole of NH4NO3 you have 4 mole of nitrogen, and this 4 mole is gonna be equal to following number of atoms. You know this formula is that N equals to number of particles divided by Avogadro number. And now you're given the number of moles, you know the Avogadro number, you just don't know this number of atoms in this case. So this would be N equals to N multiplied by Na. And then from here you have 4 times 6.022 times 10 to the power of 23, and this would be 2.4088 times 10 to the power of 24, and the number is right here. Okay, so now we're gonna continue. Compare the mass of 44.8 liters of CO2 gas. It shall need to say over here at STP, but we're just assuming that you know it, with 24.08 times 10 to the power of 23 molecules of hydrogen. So you're not given the atoms. It's not atoms. It is actually molecules. Okay? So let's first of all write the formula N equals to V over VSTP, where this is again the number of mole and V is the volume given, and then and this is gonna be volume at STP. It would be 22.4 liter per mole for 1 mole. Okay, so now let's find the number of moles for the CO2. So you have here N equals to 44.8 liters divided by 22.4 liters per mole, and this would give you 2 mole. Now we're going to use the other formula we have, N equals to M over MM, which is the molar mass, and then from here you have number of moles. You can find the molar mass from the periodic table to find the mass of it. So your mass would be N multiplied by MM, and then if you check out from the periodic table MM of CO2, you got 12 for carbon, and then you got 16 for oxygen. Now you got 44 gram per mole. And then from here you already know the number of moles. 2 mole multiplied by 44 gram per mole, this would be 88 grams. Okay, now let's check out the mass of, this is the mass of CO2. Now let's check out the molecules of hydrogen. So you have this, the formula again, N equals to N over Na. So we got altogether 3 formulas, guys. So one of them is this, N equals to V over VSTP. The other one is N equals to M over MM, mass over molar mass. And then N equals to N over Na, which is number of particles given divided by Avogadro number. In all of the cases, you can find this denominator. VSTP is, you know, the number is 22.4. Molar mass, you find it from the periodic table, and then Na, you know, the number is 6.022 times 10 to the power of 23. So now you're given number of particles. You need to find the number of moles. N equals to 24.08 times 10 to the power of 23 divided by 6.02 times 10 to the power of 23, which is giving you exactly 4 mole of H2. And then using this formula again, you're gonna find M equals to N multiplied by MM. If you check out from the periodic table, molar mass of hydrogen is 1, so you have 2 times 1, and then it would be 2 gram per mole. And then from here you got 4 moles, so 4 mole multiplied by 2 gram per mole, and this both cancel each other out. Now you got 8 gram. So altogether you found that MCO2 is 88 gram, and then MH2 is 8 gram, and that's why this one is bigger than the other. Okay, so question 9. Write down the balance symbol questions for each of the following chemical reactions, converting names to needed chemical formulas. So zinc metal, you know that from periodic table, you write it here right away. Reacts with hydrochloric acid. We have covered this many times, even last year's lab too. So last semester's lab. So hydrochloric acid is this. And then on top of it, we get the product of zinc chloride and hydrogen gas. You know that the hydrogen gas is this one, and zinc chloride is gonna be like this. Well, you may ask us, how do you know that zinc chloride would have this formula? Again, we need to look back to our previous material that we covered last year. So if you check out the zinc from the periodic table, you will find that atomic number of zinc is 30. And then you would write the electronic configuration, 1s2, 2s2, and then 2p6, 3s2, 3p6, and then 4s2 and 3d10. And then we know that the chlorine has the electronic configuration as follows. So chlorine is 17. So this would be 1s2, 2s2, 2p6, 3s2, 3p5. And then we know that because zinc is a metal and chlorine is non-metal, if you check out the periodic table, you would see the location. Metal will lose electron, and it will lose 2 electrons from here, while non-metal will get 1 electron to complete the octet. So if you lose 2 electrons, zinc become plus 2 charge, meaning valency is going to be 2, and then chlorine gaining 1 is going to have the valency of 1. And if we go the shortcut way, 1 is going to go down, and then 2 is going to go down like this, and the formula would be zinc chlor 2. Okay, so and then we need to balance this. We got zinc. So 1 zinc, we're good. We got 2 hydrogens, 2 chlorine. We need to multiply this by 2. Now everything is good on this side. And then we're going to go into the second part of the question. It's telling us iron 3 hydroxide. You need to know that hydroxide is OH from the last term. So OH ion. And you know that the hydroxide has a valency of 1, and it's given us the iron got the valency of 3. So 3 goes down here, and then 1 goes here. You would have the formula of iron 3 oxide like this, 3 hydroxide. Reacting with sulfuric acid, you need to know this too, that it is H2SO4. Let's say you didn't know what is sulfuric acid. Let's go, in this case, to products. So it's telling us iron 3 sulfate. So again, you got the iron with 3 valency, and then sulfate, you needed to know from the last term, it is SO4, and it has a valency of 2. So 2 comes here, makes it 2 in here, and then 3 comes here, makes it 3 here. So the product is iron T2SO4 3. And then we got the product of water molecule. So you have the product of water. And let's say you didn't know what is sulfuric acid, right? So you can see from here, this is a double displacement reaction. How? I can tell you. So you see this OH in here, and then if it is an acid, it comes with hydrogen ion. The H and OH combine together, and they make the water. With the OH of hydroxide. So, and then this SO4 needs to come with hydrogen, and then you can find that SO4 has a valency. We know that SO4 has a valency of 2, and then hydrogen got the valency of 1, and then 2 comes here, making like this, and then 1 goes here. It's just written as like that. And then we're going to do the balancing. So you got 1 iron, so I'm going to put 2 iron in here. And then what do we have? So we got SO4, we got 3 of them, so I'm going to put 3 in here too. So sulfates are good, irons are good. And then let's combine the hydrogen. So you have here 3 OH on the left side, and you've got how many hydrogens? You got 6 hydrogens, 6 times H. So, and then what do we have here? We're gonna do, sorry, I forgot to write that. I made a mistake. So it is in here. So right now you have 6 OH, and then you've got 6 hydrogens. If you add them up, so altogether you have what? 12 hydrogens and 6 oxygens, right? And this is actually 6 times water. Do we agree? And that's why you're going to put 6 in front of this and everything would be fine. Okay, now we're done with that. Okay, in question 10, it is talking about copper sulfate crystal. So even from here you could get the idea what is the sulfate. So you got the copper with the valency of 2, and then sulfate with the valency of 2, because there's both 2 and 2, they come here and then cancel each other out, giving you copper sulfate. And then you have the hydrate with the 5 molecules of water. So now it is asking us to find the molar mass of copper sulfate crystal hydrate. So the molar mass, I told you, for the crystal hydrate, you just need to add up this water. So copper, you can see from here there's 64, sulfur is 32, oxygen is 16, so 4 times 16 plus hydrogen, we have how many? So we got 5 moles of water, so it would be 5, multiply in the brackets 2 hydrogens plus 1 oxygen. Okay, so altogether it's going to give us 64 plus 32 plus 64 plus 90. And then from here you got 250 gram per mole. And then calculate the percentage of oxygen atoms in copper 2 sulfate crystal from the total amount of atoms in molecule. Calculate the percentage of oxygen atoms. So you've got copper sulfate hydrate, right? Let's calculate the number of oxygen atoms here. In 1 mole of copper sulfate, you've got 4 plus 5 times 1, it would be 4 times 1 plus 5 times 1, you've got 9 mole of oxygen, right? Oxygen. And then let's check out the total number of atoms. So you've got here copper, which is 1 mole of copper, and then 1 mole of sulfur, 1 mole of sulfur, and then you got 10 mole of hydrogen. So if you add them up together, you would have 9 plus 1 plus 1 plus 10, and this would be 21 moles of atoms, right? Total atoms. Now it's asking you calculate the percentage of oxygen atoms, which would be 99 over 21, and then you would multiply by 100 to get the percentage, and this would be somewhere 40.30%. Okay, and then now we're gonna go into question 11. Considering the given reaction below, answer the following questions. Calculate the mass of reacted ammonium hydroxide. So ammonium is, again, you need to know that it is NH4. So it is asking us mass of this guy. So grams of this guy, it is asking from us. If 6 moles of ammonium chloride were produced, so 6 moles of this guy were produced. So first of all, we need to know that we're going to do the balancing. So let's check out here. I've got 3 hydroxide ions. So I'm going to multiply this left side by 3. So now I have 3 ammonium on the left side. Let's multiply this by 3. And then let's check out the iron. So you got one iron, so iron is fine. And then 3 chloride and 3 chloride here. So now everything is balanced. So it is asking you to calculate the mass of reacted ammonium hydroxide. So as you see here, so 3 moles of ammonium hydroxide is giving 3 moles of ammonium chloride. This is all these coefficients are giving you the ratios. And then 6 moles of ammonium chloride would be getting from 6 moles of ammonium hydroxide. So now you have the mole amount of ammonium hydroxide, N equals to M over MM. And now let's follow the step. Now it is asking us the mass of it. We can find the molar mass of ammonium hydroxide. You have here 1 nitrogen, so 14, and then you got 5 hydrogens, which is 5 times 1, and then 1 oxygen, which is going to be 16. So this would be 30 plus 5 would be 35 gram per mole. And then you have M equals to N multiplied by MM, and this would be 6 mole multiplied by 35 gram per mole, and this would be mole cancels out, 210 gram of ammonium hydroxide. And that's the answer. And then now it's asking calculate the amount of oxygen atoms for 3 moles of iron hydroxide. You can see here that iron 3 hydroxide is here. So iron 3 hydroxide is given to us like this. And then 3 moles of iron hydroxide. Now you have 1 mole of iron hydroxide. Let's see how many moles of oxygen do we have. We got 3 moles of oxygen, right? So for 3 moles of iron hydroxide, you automatically will have 9 mole of oxygen. 9 mole of oxygen atoms. But now it's telling us amount of oxygen atoms, not the number of moles, not the moles. Okay, it is telling us oxygen atoms. So you need to use the formula N equals to N over Na. And you know the Avogadro's number here, you have the number of moles. So N would be N multiplied by Na, and then that would be 9 times 6.02 times 10 to the power of 23, and this would be 5.4088 times 10 to the power of 24 oxygen atoms. Okay, so now question 12. It is telling us fill in the gaps with the corresponding number. You're given at SDP 64 grams of hydrogen, oxygen, and then SO2. So you need to get the idea from here that if you have 64 grams, the formula is N equals to M over MM, right? You're given you're only given mass, and you're given molar mass because you can find it from the hydrogen, and then it is asking you the mole, which is this guy, right? And this would be, so for hydrogen, molar mass for hydrogen is 2 times 1, which is 2 gram per mole, right? So when you come back here, it would be 64 gram divided by 2 gram per mole, and this would be 32 mole. So 32 in here. So now it is asking the number of molecules of oxygen. So you need to go with the formula N equals to N over Na. You're given, before that, we need to know the number of moles, right? Number of moles to find the number of molecules. So for this one, we're going to use the formula again, N over mm. So N equals to, this is our first step, M over mm. So the molar mass of oxygen, what is that? We can find it from the periodic table, is 2 times 16, which is 32 gram per mole. And then from here you have 64 grams of oxygen, and then 32 gram per mole. And then this would give you 2 mole of oxygen. And then now the second step is this formula I told you, N equals to N over Na. Now you have number of moles, Avogadro number, you can find the number of molecules. Okay, so number of molecules, N would be N multiplied by Na, and this would be 2 times 6.022 times 10 to the power of 23. This would be 1.2044 times 10 to the power of 24. So that is that. And then now it's asking the liters of SO2. Now for this one, we find again the number of moles first. So N equals to M over mm. We need to know that the molar mass of SO2 is going to be 32 from the periodic table, plus O is 16 times 2, which is 64 gram per mole. And then you know that it's given to you, it is 64 grams divided by 64 gram per mole, and this would be 1 mole. And then the second step, you're going to use this formula, N equals to V over V STP. You know that at STP, 1 mole of any gas would be 22.4, so N would be multiplied by V STP. You know the number of moles now. You know V STP, you can find the volume in liters. So this would be 21 multiplied by 22.4, so 1 mole multiplied by 22.4 liter per mole, and then mole and mole cancels out, it would be 22.4 liters. And this is the answer for here. Okay, so now let's move on to the question 13. So it's telling us that instructor brought 2 samples to lesson for the topic stoichiometry. 28 grams of iron and 200 grams of calcium carbonate. Compare the mole amount of iron and calcium carbonate for the given amounts. So it's super easy. We need to find the mole of iron. This would be M iron divided by mm iron, and you can find from periodic table that the iron atomic mass is 56. This would make it 56 gram per mole, and then this would be 0.5 mole. And then N calcium carbonate would be M calcium carbonate divided by mm of calcium carbonate. You can find the molar mass of calcium carbonate from the periodic table. It would be 40 plus 12 for carbon, 40 is for calcium, and 3 times 16 for oxygen, and this would make it 100 gram per mole. So since you're given 200 grams, so it would be 200 gram divided by 100 gram per mole. This would be 2 moles. Okay, so now you can see that N iron would be less than N calcium carbonate, because this is 0.5 and this is 2. Now calculate the mass percentage of metal for the 200 gram of calcium carbonate. So you know that over here you have calcium itself is the metal. The rest are non-metals. So we found from here that we got, for 200 gram, we got 2 moles of calcium carbonate, right? For 2 mole of calcium carbonate, you have 2 moles of calcium. Do we agree on that? I hope you agree. So 2 moles of calcium in 2 mole of calcium carbonate. You can find that mass of calcium. It's asking you mass percentage. Mass percentage meaning that let's say a mass percentage of calcium plus mass percentage of carbon plus mass percentage of oxygen will add up to 100% because they are making this compound, right? So now you've got 2 mole of calcium. You know the formula N equals to M over mm. Now you have the mole number, which is 2, and the molar mass of calcium is going to be 40 if you check out the periodic table. So M would be 2 times 40, so 2 mole multiplied by 40 gram per mole, and this would be, mole cancels out, this would be 80 gram. So now you have 200 grams of calcium carbonate, and then inside you have 80 gram of calcium in this compound. And now you can find the mass percentage by just doing this. I forgot to multiply this by 100, and then this would be 80 over 200 multiplied by 100%, and then 100 and 200 cancels out. It would be 40%. Okay, so now we're going to move on to the question 14. This is more about a logical question. You're given a compound Bc2. It's not boron, it's not carbon. Nothing has been told to you about it. Actually, you don't really care about it. You need to find the amount of the substance. Now you need to pay an attention over here. You've got 6 times Avogadro amount of atoms. So if I have 1 mole of Bc2, I've got 1 mole of B and then 2 mole of C, right? So altogether it would be 3 moles of atoms. Do we agree? I hope you agree again. So now you've got, if you have 6 mole of atoms, you can automatically see that in this case it would be 2 moles of Bc2, because you will have 2 moles of B and then 4 moles of C, which will add up to 6 moles. That's why the X would be 2 mole. Okay, now calculate the molar percentage of B element. Again, the molar percentage. So molar percentage would be percentage of B, the molar percentage, and then percentage of C. They add up to 100%. Okay, so it's telling you about 3 moles of Bc2 compound. Again, if you check the 3 moles of Bc2, you have here 3 mole of B atoms, and then you got 6 mole of C atoms. So altogether it would be 9 mole of atoms, right? 9 mole of atoms. Now it's asking you to calculate molar percentage of B element. So you've got 3 mole of B you want to find the B molar percentage, right? Over 9 mole of all of atoms, because you have altogether 9 moles of atoms, and this would be 1 over 3, and this would be 33.33% if you multiply by 100. And that's a logical question. So to be honest with you, it doesn't matter if it's 3 moles, if it's 1 mole, or if it's 2 mole. It's going to be the same thing, because if I check this number, look back here. So 1 mole of BC2, right? So how many moles of B you have? 1. And then how many moles of atoms you have? Okay, 1 over 3. Now let's check out 2 moles of BC2. You got altogether 6 moles of atoms. And then how many moles of B you have? Which is 2. It would be again 1 over 3. And then over here, 3 over 9, it is 1 over 3. So the percentage, mass percentage, molar percentage doesn't change with the moles. Okay? So question 15, this is a bonus question. It is given to you in case, let's say, you lost some marks in question 1 to 14. You can compensate if you write questions in here. You can fill up to those deducted marks. So you've got benzene, which is C6H6. It's a colorless light yellow liquid chemical at room temperature. It is used primarily as a solvent in the chemical and pharmaceutical industries. 2 chemical reactions can be used to produce benzene. So we're trying to produce benzene. And we have 2 reactions, okay? It's not 1 reaction. There are 2 reactions back to back. So we have calcium carbide reacting with water, giving us C2H2 and calcium hydroxide. And this C2H2 is giving us the product. You don't need to know the names of this stuff. You only need C6H6, which is given to you. So now it is asking you balance the given reactions. So it is super easy. Let's check out, start from the bottom. You've got C6H6. So if you multiply this by 3, everything is good. And then for this guy, you have calcium carbide. So you got calcium 1 and then calcium 1. You're good. Hydrogens. You've got 2 hydrogens here, but you have 2 plus 2 and then 4 on this side. So we're going to multiply this guy by 2. Now let's check out oxygens again. So we got 2 oxygens on the left and you got 2 oxygens on the right. So everything is good. Carbons, hydrogens, calcium, everything is good. So now you have these reactions. So you're going to write them in here. Calculate the mass of benzene produced if 18 grams of water is used. So 18 grams of water were used to calculate the mass of benzene. Now we need to convert all of the grams into moles first. And then we're going to work with the moles on chemical equations and find our stuff. So 18 grams of water. Let's find, we know the formula N equals to M over MM. And then molar mass of water would be, again, 2 times 1 plus 16. It would be 18 gram per mole. So this would be 18 gram divided by 18 gram per mole. And this would be 1 mole. So it is telling us calculate the mass of benzene produced if 18 grams of water is used. So we have this formula, chemical equations. You know that 1 mole of water was used, 1 mole of water. So if we write it down, so calcium, let's write it here. So calcium carbide plus 2 moles of water gives you 1 mole of C2H2 and then 1 mole of calcium hydroxide. You can either do it with proportions or up to you, whichever way you want to do. You can find the omega. There are many ways to do this. So you can find 1 mole divided by the coefficient of the water, which is 0.5 mole. And then from here, you know that the coefficient of C2H2 is 0.5 mole. Or you find a ratio from 2 mole of water. So you know that from 2 mole of water, you get 1 mole of C2H2. And then from 1 mole of water, it would be 0.5 mole of C2H2 automatically. So now that you have the C2H2, which is 0.5 mole, you know that 0.5 mole goes in here because we're going to use it as a reactant for our second reaction, right? In the first reaction, we got it as a product, and then we used it as a reactant for our second reaction, okay? So this is a tricky part of this. So now you have, in the second equation, you have 3 moles of C2H2 from the balanced equation. You got 1 mole of C6H6, right, benzene. Now you're given that 0.5 mole C2H2 goes in, you automatically will have, let's do this with proportion, C6H6, and then 3x would be 0.5, and then x would be 0.5 over 3 mole of C6H6. So now you have the mole of benzene. You need to find the mass of benzene. The mass of benzene, again, we're going to use the formula N equals to M over MM. You have the mole amount. So you have mole amount. You can find the molar mass of benzene, which would be, you got 6 carbons, it would be 6 multiplied by 12, and then 6 hydrogens will be added. This would make it 78 gram per mole. And then from here you have molar mass. You can find the mass of this. The mass would be N multiplied by MM, and this would be 0.5 over 3 mole multiplied 78 gram per mole. Mole cancels out. 78, 3 cancel, give 26, and this would be 13 gram of C6H6, which is benzene. That is the answer for here. Okay. And then calculate the amount of hydrogen atoms in benzene that is produced from 128 grams of calcium carbide. Again, we need to find the mole amount in order to use the chemical equation. So let's find the molar mass of calcium carbide, which is 40 for calcium, and then carbon is 12, so 12 times 2, which would be 64 grams per mole. And then we know that N would be M over MM. We're given that it is 128 grams divided by 64 gram per mole, and this would give us 2 moles. Okay, so calculate the amount of hydrogen atoms in benzene. Again, I'm going to write the equation, so just for our convenience. Normally you can just use it from top. So calcium hydroxide. So it's asking calculate the amount of hydrogen atoms in benzene. So let's solve the first equation first. You've got here 2 moles of calcium carbide. You don't know how many moles comes out from C2H2. We need to find the mole of C2H2 because we will use it as a reactant for our second reaction, right? Which is, so C2H2, sorry, I'm just gonna write it in blue. So 3 C2H2 give us C6H6. So now you know from this ratio is that 1 mole of calcium carbide gives us 1 mole of C2H2, right? So 2 moles of calcium carbide will give us 2 moles of C2H2. So now you have C2H2. We're going to write it in the bottom here. So 2 moles of C2H2. We can see from 3 moles of C2H2 you get 1 mole of C6H6, and from here you would have X mole, and you can do 3X. So do proportion. 3X would be 2, X would be 2 over 3 mole of C6H6. So you have the number of moles of C6H6. Calculate the amount of hydrogen atoms. So it is asking us number of particles exactly. So you have the formula is that N equals to N over Na. We know this formula. But in this case, it is asking us the hydrogen atoms, right? So we know that for 1 mole of C6H6, you got 6 mole of hydrogens, right? 6 mole of hydrogen atoms. And then for 2 over 3 mole of C6H6, you would have, let's say, X mole of hydrogen. So let's do this balance. It would be X would equal to 2 over 3 multiplied by 6, and this would be 4 mole, right? 4 mole of hydrogen. And then now you come back to this equation. You have the number of moles, you have the Avogadro number, you need to find this number of particles. N would be N multiplied by Na, and this would be 4 mole multiplied by 6.022 times 10 to the power 23 atoms. I'm just going to write all of the units per mole. So mole cancels out. This would be 2.4088 times 10 to the power of 24 hydrogen atoms. And that is that, guys. Thank you very much for watching.